Good morning, good afternoon, good evening, wherever you may be in this part of the world. Welcome to another beautiful session of my presentation series. And this time, the presentation topic is importance in the application of mobile substations and mobile transformers and mobile breakers. My good name is John Kweku Amootu. I've been a professional electrical engineer for the past 31 years practicing in the United States of America. Now, let's talk about YouTube. Basically after watching my video, if you like my presentation, don't forget to select the like button as shown over here. And also, there are tons of our presentation materials that is on my YouTube channel. This is the name of my YouTube channel. Just go in there, and there are tons of presentation materials for you as a young engineer that is starting your career in the area of power systems, or an experienced engineer, or development engineer, or consulting engineer. And as experienced engineers or consulting engineers, we all need a refresher. So this can be a good channel for you for refreshing yourself on a daily basis. Okay, so don't forget to subscribe my channel. This is the subscribe button. Also, don't forget to share. Okay, so now let's take a pivot on this slide. Okay, so let's talk about the rationale, the reason behind why we need a mobile transformer or mobile substation, and or a mobile breaker, And the reason why we have a mobile breaker, let me explain the reason why. Sometimes you can have a mobile transformer that is basically on the trailer, and on the high side, let's say if the high side is, let's say, 115 kV, 230 kV, right? You'll see that there won't be any high side breaker. So sometimes that is when you utilize a mobile breaker to integrate it to the high side, so that it should be easier for the protected relays to trip that breaker on the high side if need be. So now let's take a deep dive into the rationale behind needing a mobile transformer. Okay, so if you have a planned maintenance coming up, sometimes the maintenance unit or the asset management group utilize it for an emergency purposes, and that is through planned maintenance. As much as it is good to plan the use of a mobile substation, mobile transformer, to be utilized for plant maintenance, usually the maintenance group or the asset management and the reliability group, kind of try as much as possible to shy away from that, to limit the use of their mobile transformers or substation to utilize it for plant maintenance. They want to reserve it for real emergency need. Okay, so on the other hand, if need be, sometimes they don't have a choice to use it for plant maintenance. Okay, so basically the first statement speaks for itself to allow maintenance on the existing equipment. So let's say if you have a substation, right, that has a fixed transformer, and you want to perform maintenance on the equipment, but looking at the substation and the customers that it feeds, you can't basically afford a 1 week or 2 weeks maintenance. Especially if you are performing a major maintenance on a transformer, right? That is typically a 6-year interval, right? And that major maintenance can take about 2 weeks to 2.5 weeks, especially to do all the maintenance, disconnection, maintenance testing, then evaluating the results, and basically after the results are good, reconnecting and basically energizing. That takes about 2.5 weeks. So if you have a critical customer or a critical load, right? Typical example is data center, communication, hospitals, right? Those are critical infrastructures, right? Okay, and you can't afford to take that long duration of outage. So basically, you have to come, basically plan the utilization of a mobile transformer or mobile substation, right? So that is when basically you utilize basically mobile substation or transformer to allow you to maintain that existing equipment at the substation facility. Okay, so like I indicated, the goal of asset management, reliability growth, and also compliance growth is to reduce the use of the mobile substation and basically set aside the mobile substation or the mobile transformer for real emergency use. So basically, what they do is during this plant maintenance period, they plan it during non-peak period, and they basically put in the optimization to basically, perform the maintenance, when they can basically transfer the load on another feeder, But if you don't have an N-1 contingency or N-2 contingency, then you don't have a choice. And let's say if there's the need to perform, take the transformer out of service, then that is when you really need the mobile transformer or mobile substation. Okay. So the second point is increasing load, right? Okay, so as you all know, there's gradual increase in load, right? Especially data centers, construction of commercial facilities, construction of industrial facilities, right? So with all this, and matter of fact, housing, and they are building a lot of housing, high structures, towers and all those things. That itself is all, part of the increasing load. So you have to account for that. And matter of fact, to make it worse, during summer, all those air conditioning, has to come up, and those motors consume a lot of, starting, especially the starting current and the starting reactive power. Basically, that can basically cause a sag in the voltage and can cause power quality problems. So there's the need to account for that. So sometimes, you can have that increase in load due to construction, activities, building new facilities, and I made mention of that. You said healthcare facilities and also industrial facilities. So those, and also apartments, high skyscrapers and all those things, and commercial facilities. That also accounts for increasing load. And sometimes, if some of the existing facilities, industrial facilities, let's say they are performing a modification, adding major, infrastructure, to the existing facilities, and so that itself, can cause, can result in an increase in loading, and that has to be accounted for. On the other hand, there's that regular, increasing loading during summer, right? And summer load, like I indicated, the air conditioning loads, and winter is heating, right? And needs to be accounted for. The other factor or the other criteria, that basically supports the rationale behind needing a mobile transformer or substation, it's a false outage, and this can be either related to weather, right? And basically we have seasonal floods, right? Seasonal floods and hurricane. Hurricane can cause a lot of destruction, tornadoes, right? We've seen tornadoes wipe a lot of substations, and hurricanes wipe a lot of substations, floods, especially floods after hurricane, can wipe a lot of substations. So that is when the mobile transformer and substation, becomes needed. It's needed for that emergency, And the other one is equipment failure. You can have basically, due to neglect, not managing, the equipment, the asset management, you can have an equipment failure, right? And sometimes, during lightning, right, strikes or impulse voltage strikes, right? Sometimes it can basically penetrate, the winding of the transformer and can cause an incipient damage to the transformer that itself manifests, with time, right? And that can cause equipment failure, right? Sudden equipment failure. Okay. The other one is sabotage and substation attacks, and we've seen a lot of these. Sometimes cyber security attacks and physical, substation attacks. The other one is weather related, and I made mention of that. This one is due to floods, seasonal floods, hurricane, tornado, etc. So now let's take a look at some pictures. I have always made mention in my previous presentations that pictures are worth more than 1,000 words. I can put thousands or 10,000s of words on this slide, right? Trying to explain something. But if I put a picture there and I start describing immediately, it's basically you can just grasp what I'm talking about. Okay, so now let's go through what typical mobile substation looks like. Okay, so as you can see, the reason why they call it mobile, right? It means that it can be moved from point to point. So definitely it is on the trailer with ties, right? So probably an 18-wheeler, right? And during the design of this trailer with the ties, basically the weight of this component, is incorporated so that the ties and the bed, they call it this one the flatbed, can withstand that weight for longer period. Because I've seen mobile substations, right? Mobile transformers being used, in typical some substations for 10 to 20 years, right? So think about it. If this weight is on this flatbed with supporting ties for that long period of time, think about it. So it is designed to withstand. But not, on the other hand, sometimes you get the ties are being flat, right? And you have to basically put in some air to bring it up a little bit. Okay, so now let's talk about the components, right? Okay, so this is the transformer part, right? And this is, of course, the bushing, right? This is basically the cooler, basically that helps to take the oil out. So these are the, as you can see, these are the pipes, right? So the piping, the hot oil comes in here, goes through this heat exchanger or radiator, basically to remove the heat from the hot oil. Then it goes back into the transformer at the bottom, and basically it gets heated by the winding that is hot, and basically it takes the heat from the winding through a conduction process. Then basically the hot oil rises up due to a convection action, right? So these are the two phenomena that due to heat transfer, that is conduction from the hot winding, the copper basically, as you have a current flowing through the copper of the winding, basically it gains heat, and that heat has to be dissipated into the oil. So the transfer of heat to the oil, then basically the oil expands and basically it rises up, and through a convection action it rises up, then it flows here, then the heat exchanger takes the heat away. So this one is a heat exchanger or a radiator, right? Okay, so on the other side, it's a GIS scheme or a switchgear, basically, like a breaker scheme, right? Okay, so that is able to operate the high side of the mobile substation, right? Because you are integrating this side to this tower structure, right? Okay, let's say 115 kV or 230 kV, right? It has to go through some disconnect switches and also this high side breaker, right? Okay, so as you can see, this is the high side bushings, and this most likely should be the low voltage side bushing. Okay, so to operate the high side breakers, right? Okay, this is the control panel for the high side breaker, and like I said, this breaker can either be an AIS or GIS, gas operated breakers, or air insulated breakers. Okay, so this is also another beautiful picture, right? Okay, so like I indicated, this one is a flatbed, right? With ties to support the weights, right? The flatbed and the ties both support the weight of the mobile substation, right? Okay, so this one is their mobile transformer, right? Okay, so with its rating, it could be rated at 20, 25 MVA, 45 MVA, and I've seen rating all the way up to 100 MVA. So as you can see over here, this is the high side and this is the low voltage side. Okay, and this one is the controls for the mobile transformer. Okay, so on this side, right? Okay, it's your switchgear, right? Your circuit breaker, and like as you can see over here clearly, this is one is the gas insulated switchgear breaker. So it has a breakers that are basically insulated in a gas, right? Okay, so this are your bushings, right? Phase A, phase B, phase C. This one is integrated to your high voltage side, that is 115 kV, 230 kV, 345 kV, right? Okay, so it comes in here, and like I indicated, this one is a GIS, right? And basically, SFSS gas, they utilize SFSS gas to insulate the internal component, right? CTs, PTs, the breakers, etc. Okay, so this one is integrated to the high side of the transformer, right? Okay, so this one, as you can see over here, let me refresh this one. This is the low voltage side, and sometimes you can have two low voltage windings, right? Okay, so sometimes you can have let's say 14.8 kV on the low voltage side, and let's say 13.2 kV. Okay, so these are the low voltage windings that you can connect, based on what low voltage system you have. If you have a 14.8 kV voltage, then you can connect to this one, and let's say 13.2 kV, then you can connect to this one. So this one is the low voltage side, and this one is the high voltage side, right? Okay, so now remember I made mention that sometimes you have a mobile substation and with no breaker on the high side of the transformer. So then it becomes necessary that you should have a high side mobile breaker. So this one is a high side mobile breaker that you can integrate to the high side of a mobile transformer. Okay, so as you can see over here, you have 3 line side and going side. And sometimes some of these substations, and switchgears can be containerized, right? Okay, so as you can see over here, right, these are the connections to the high side, right? 115 kV, 230 kV, 115 kV, 230 kV, right? And a lot of these things, it's done based on their containerized modularized scheme comes if based on the environment. If it's going to an environment where there's a very high contamination, high dust, and especially the refineries where you have a lot of oil waste, then basically it becomes and also the mining areas, it becomes industry that you can utilize containerized switchgears, mobile switchgears. Okay, so let's take a look at another picture, a beautiful picture, and basically this one is a robust structure, as you can see, hydro ties with a flat bed, as you can see over here. Okay, so like I indicated, this one it's a mobile transformer, right? Okay, so you have the high voltage side, that is on this side, as you can see over here. This is how you identify the high voltage side of the transformer and the low voltage side. You're able to differentiate. It's the size of the bushing, right? Okay, the high voltage side bushing is longer and bigger, and the low voltage side is shorter, and thin. Okay, so as you can see over here, this one is longer and bigger. So this one is the high voltage side, and this one is the low voltage side. Okay, so these are the coolers, as you can see over here. These are the coolers, right? So its purpose is to take the hot oil from the transformer and cool it, and basically return it back to the transformer in a closed cycle loop. And these are the tubular buses, basically from the low voltage side, and you have a disconnect switch that then after that you can integrate to your medium voltage or low voltage side switchgear that you want to integrate. Okay, so on this side you can have disconnect switches, right? Disconnect switches. So as you can see over here, this side doesn't have a breaker, it just has a disconnect switch. Okay, so this is when it becomes necessary to have a mobile breaker, high voltage breaker, to integrate to this side, so that you should be able to switch in and out this breaker, so that if there's a fault, during operation of this mobile switchgear, you should be able to trip that breaker and isolate this mobile sub. Now let's take a look at another beautiful picture. Actually, this one is work, the manufacturer's work. So as you can see, this is a beautiful compact transformer. You see how everything has been compacted in a miniature. Look at the size of the transformer. So as you can see over here, this one is the high side, right? Based on the size of the bushing, right? Okay, so this is the bushing turret, right? This is where all the CTs are located, on the high side, right? And this is the high side bushing, phase A, phase B, phase C. Okay, so on this side, like I had indicated, it's you need a switching device, right? It can be air insulated breaker or gas insulated switchgear, right? So in this case, it's a gas insulated switchgear, right? So you have an input here coming in, the line side coming in, and outgoing side that goes from here to the transformer. Okay, so this one is integrated to your tower structure, through a drop-down conductor, let's say 115 kV or 230 kV or 345 kV. Right? Okay, so on this side is the low voltage side, and I indicated that you are able to identify the low voltage side based on the size of the bushing. Right. Okay. So on this side is the switchgear. Yeah, basically this is the switchgear, and you have disconnect switches on this side, and this one is the switch gear, where basically you have the medium voltage side, let's say 30.2 kV, and probably you can have let's say 2 feeders or 3 feeders, right? Feeder 1, feeder 2, and let's say an auxiliary compartment, right? Okay. So and also you can have control panel for other equipment that are located on this okay, so this is basically a nice picture of the mobile substation, and from a different angle. As you can see over here, this one is the high side based on the size of the bushing, right? Phase A, phase B, phase C, and these are the disconnect switches arranged in a more a different configuration, and this is the low voltage side. Okay, so in between my presentation, I've changed my strategy a little bit, so in between my presentation, I tried to remind you, so if you like this presentation, don't forget to select the like button and share this presentation. You can do it now. Go ahead and do it now. And also go to my YouTube channel. This is the name of the YouTube channel. What can happen is talking to the engineer. And there are tons of presentation materials that can help you as a young engineer, as a developing engineer, as an mid-career engineer, experienced engineer, consultant engineer, to help you to basically, and experienced engineer consulting, you can refresh yourself with all these presentation videos out there. And don't forget to subscribe. Okay, subscribe. Next is another beautiful picture, and basically, as you can see over here, these are the high voltage side. I always tell you that you see the high voltage side from the size of the bushing, right? high voltage side. From the size of the bushing, that is a tall, big bushing, right? Base A, base B, base C, and these are the bushing turrets where it is filled with oil and has like cities, right? Bushing type of cities, and basically, you have the conductor comes in, and the cable comes in and get connected to the bottom part of the bushing, and this side is basically what goes to the high voltage side of the substation. Let's say, if you have a tower structure, it goes there, 3 phases, phase A, phase B, phase C. Then the low voltage side, so as you can see over here, this one has probably 12 voltage on the low voltage side. So as you can see over here, you can see 12 voltage, and now sometimes you see the 12 voltage, let's say 30.2 kV times 14.8 kV. It means that based on your low voltage configuration, you can utilize whichever low voltage bushings that I do for you. Right? These are the radiators, and also this one is the bus structure with this connector overhead. This one is switches, and of course these are the supporting ties and the flat bed. Okay, so this is an area view, they call it bird's eye view of this mobile substation, right? Okay, so you can see over here, disconnect switches, high voltage side of the transformer. This is the mobile transformer, and I indicated that if it doesn't have a high side voltage breaker, then you need a mobile high side breaker. You have to get that to integrate it to the high side. Okay, this is the low voltage side, as you can see over here, and these are the coolers or the radiators or heat exchanger that removes the oil from the transformer, cools it, and returns it back. Then this is your tubular bars, right? Disconnect switches and your medium voltage side to connect to your switchgear. Okay, so this one is a more closer picture, right, of how these bushings look like. Like I told you that the high voltage side is tall, big. So that itself. So this one should be a 115 kV, 230 kV, or 345 kV. Whatever. So that's how they look like. Okay, and this one is the bushing turret, right? So this one is filled with oil and has cities. Let's say it could have 2 or 3 cities, right? One city is used. First city used for both meter, as current transformer used for ammeter, ammeter, and the second one is for protection. Okay, so you have a city, like I said, 2 cities, right? The first one is used for instrumentation, that is for an ammeter, and the second one can be used for a watt-hour meter, or the first one can be used for an ammeter or watt-hour meter, and the second one used for protection. So these are the cities that are located over here, and of course, this one is the transformer, and on the side is basically your tubular bars with your disconnect switches. Okay, so I think I've shown you this picture before. So the high voltage side and low voltage, you have 2 low voltage side. Okay, so now let's do some comparison, with regards to the mobile substation and the fixed transformers, traditional transformers that are mounted in the substation, right? Let's take a look at the first parameters, right? The first parameters is insulation, right? Okay, so for a fixed transformer that is located at the substation, right, it utilizes thermally upgraded paper, right, cellulosic insulation material, and oil, right? And sometimes you can have no mix, right? Okay, but for mobile substation, you use Nomex and oil as your insulation. So the Nomex is basically what is wrapped on your conductor, in addition to the oil that is in the containerized container, right? So now let's talk about temperature rise. Okay, so because of the compact size, the smaller size of the mobile substation, mobile transformer, right? Definitely, everything is going to be small, right? And you have a high current, right? Based on the voltage and the MVA rating of the transformer. So it means that it should be able to withstand a higher temperature rise. Okay, so as you can see over here, the temperature rise of the mobile transformer and the substation is higher, right? Okay, so 115 plus an average design temperature of 30 plus 10 degrees for horsepower and 10 degrees for margin, right? So you're talking about 165 degrees Celsius. That's the design. Comparably, for a traditional conventional transformer, fixed transformer, you have 65 degrees Celsius average winding rise or top of temperature rise, okay, plus 30 degrees Celsius for the ampere, right, plus 10 degrees for horsepower, then 10 degrees margin. So you have 115 degrees Celsius as the total temperature which time. Okay, so flux density. Remember, I made mention that everything is small. The core has to be small, right? Because you are fitting this thing on flatbed, right? So you have a smaller cross-sectional area of right. Current density is equal to current over cross-sectional area. You have a smaller cross-sectional area comparably with the traditional, and you have a higher current, right? So what does it translate to? Your J, your current density is very high, right? Comparably to this one. Okay, then your full load losses, right? Okay, you have a 1.5% for your mobile substation, right? Because your I is higher, right? Because the full load loss is what? I squared R, right? Okay, so your resistance is also going to be high. So basically it translates into a higher losses comparably. Your impedance is also high, right? Because the impedance is a factor of the winding configuration, how tall the winding, and also the spaces, how the active components are arranged on a radial basis, right? So it's more for the axial height and the spaces in between, tall air gap in between the windings and insulation system. Right? Okay, so now let's talk about the breakers, right? Of course, the breakers are, should be part of the flatbed trailer. Switches should be part of it. Auxiliary power for you to operate the control cabinet and all those systems, heaters and all those things. On the other hand, for the fixed traditional substation and transformer, you have the breaker as part of the substation. It's probably co-located in the substation at the corner, or the switches is also part of it. It's part of you see it as basically you have the air insulated that disconnect switches before the transformer, right? And usually this one has to be operated in a de-energized configuration. And auxiliary power, you see that substation power, right? Okay, so you see there's let's say 13.8 kV, 2 for 80 volts, or 120 volts, right? Okay, so now let's talk about the nameplate characteristics. What we have out there for MVA, on the low side we have 5, on the nominal side is about 25, on the high side. Then the high voltage side rating, on the low side 35, on the nominal side about 115, on the high side about 245. Then low voltage 5 and 15. Okay. Then this one is just the weights out there, about 50 on the 95 pounds. 95,000 pounds, probably, think about probably kilograms or so. My strategy in this presentation is just to remind you guys. I know that, when you get into listening, sometimes you forget, but go to my YouTube channel. So put in this one, just go there. There are tons and tons of video presentation, technical presentations out there for, as a young engineer. You're trying to start your career up, I know sometimes it can, you be naive, and it can frustrate you. But this presentation basically helps you to gradually develop yourself. And mid-career engineer, developing engineer, experienced engineer, consulting engineer, this can be a refresher for you. Okay, so if you go there and you like, matter of fact, you like this presentation, don't forget to select the like button, and also don't forget to share this presentation. And if you like the presentations out there in my YouTube channel, don't forget to select the subscribe button. So now let's talk about the advantages of a mobile substation, right? Okay, so what does it do? Reduce the maintenance cost, right? Yeah, basically the reason being that sometimes I've seen basically mobile substations, mobile transformers being utilized basically to provide basically integrated to a main substation, for longer periods, right? Okay, so you end up reducing the maintenance cost. Then also, if you have to have a planned maintenance on substation equipment, let's say mobile transformer, right? Okay, so once you are able to integrate that, you end up basically, being able to perform, basically, reduce the turnaround of maintenance. The next one is reduce the support, because what it is the traditional one, the fixed transformer. But basically, you need space for it, right? You need to basically, dig the foundation, put in basically, ground mark and all those connections, right? So, but with this, you don't know, everything is on the flatbed on an 80 way, right? So you reduce the support works that is required for the fixed bottom transformer. And also it can be deployed rapidly, because they are ever ready, they are maintained regularly, and they can be deployed. And one of the things that if you are deploying, it, you need to make sure your travel path, right, and the size and the road can handle that part, because you have basically you have overhead bridges and all those things. So you want to make sure that you navigate and basically evaluate your travel path to make sure that you wouldn't have any hindrances during the travel or deployment of this mobile substation. Okay, so the next is reduce the dismantling cost, right? And that is perfectly. This one is already assembled, right, before it gets there, right? Everything, you're ready to basically plug and play. You're ready to connect it to the high voltage side and also connect it to the low voltage side. So basically, think about it. Less time that you use and basically that translates into maintenance cost. Reduce the maintenance cost, right? You're spending less time, less labor, less material, to integrate this to the existing substation. And also space, right? You are utilizing smaller space. And because, think about it, the circuit breaker disconnects switches and all those can take bigger space in the substation. Okay. And they are delivered ready to be connected to the grid, and basically they help to provide rapid short and long-term benefits. Next is you can go to this another reminder, and definitely I know that you like this video, and if you like it, don't forget to select the like button. As you can see, the thumbs up. Okay, share with your friends, and also if you go to my YouTube channel, don't forget to select the subscribe button. With that, thank you so much, and look out for more presentations, right? More excellent topics, that will help you as professional engineers out there. Thank you.